Hello, D4D. I'm Nick Colley. Thanks for joining us on tonight's Community Hangout. We've got a wonderful tutorial in place. One quick announcement. If you're watching this before end of September 2017, we have announced our second hackathon. The second hackathon is going to be on from September 29th to October 1st. Keep checking our Twitter or in the general channel in Slack, and all the details will be posted there shortly. So joining me tonight, we have Josh from DataQuest. Hello, Josh.
Hey, how are you?
Doing very well. How about yourself?
I'm fantastic.
Excellent. So Josh, you've been recently working on one of the D4D projects doing some web scraping, and we're kind enough to volunteer to come on and host a tutorial on this. How did you kind of get involved in the web scraping and doing grabbing data from the internet?
Yeah, look, I mean, I work for a company called DataQuest, and we teach data science online. As part of being in the DataQuest team, we're always teaching people data science, but we're often pulling down data for ourselves. And so I think I got my first little web scraping project that I did as a sort of as a learning thing was pulling down some of the presidential election results. In the sort of days after the election a few months ago, and kind of got into it with this. And this tutorial that I'm going to present today is actually based on a blog post that we published a few weeks ago, which was done. I edited the post, but it was written by one of our students, Alex, and he's based in Romania. It's about 2 a.m. there, so he can't be with us to present this, but I've sort of prepared this with him, and I'm going to present his tutorial.
Awesome, excellent. And per the usual, for those watching online or part of the D4D community, we do have the YouTube channel up, the comments, and the Slack channel up. So feel free to ask questions, and we'll make sure we get those answered during this tutorial. Josh, the floor is yours.
Fantastic. So I'll share my screen so everyone can see what I can see. So a little bit of context. I work for a company called DataQuest, and we basically have an online interactive course where you can learn data science in your browser. And this post was written by a student of ours who's been studying with us for about 6 months, and he actually works for us managing our community. His name is Alex, and so he published this blog post, and all the code that we're going to work with today is available in this post, and we'll put a link there so that if there's anything that you want to do, if you want to follow along afterwards, and you prefer to copy paste the code, we can help you with that. So I wanted to start with a little bit of a sort of an overview of what web scraping is and what the sort of higher level process is. So imagine you've got a website. The gray square represents the website. The red dots are individual pages within that website. And when you're web scraping, there's sort of two phases. You first need to sort of fetch the web page, okay? And that's called making a request. And what happens when you make a request? It's the same thing that happens on your web browser when you're surfing the net, is that you request the page, and it sends back a copy of the page, and then you have the page locally on your computer, and that's what your web browser shows to you. With web scraping, you then take that page that you've fetched, and inside that page is lots of pieces of data, and then you do what's called parsing the data. So you basically extract the data out of that saved copy of the web page. This sort of high level thing is important to keep in mind, because when you're trying to create a data set from a website that collects lots of data, you want to try and, if you can, minimize the number of requests that you make. If you can collect the same amount of data by doing 70 requests instead of 3,000 requests, it's going to be quicker. It's going to be less taxing on the web server that you're pinging, and you also need to do sort of less work to sort of obscure that you're not a regular web user, because some websites are trying to stop you from from collecting that data. So because you want to minimize these number of requests, it's very useful to start with a plan, to have a really good idea of what you're doing, what data you want to collect, so that you can think about it from a sort of high-level viewpoint, and be sort of smart with how you collect your data. So what we're going to do today is we're going to look to collect data from IMDb. We're looking at ratings of movies, and we also want to compare that with data from movie ratings from Metacritic, so we can compare the ratings that movies get at both. So we'll start with the idea that we want to go for, we want to try and collect about 2,000 movies. And so you can immediately think that if you have to fetch ratings from 2,000 movie pages on IMDb, sorry, and 2,000 on Metacritic, that immediately we're going to have to make 4,000 requests. Okay, so that's where we're going to start from. But we're going to see if we can identify a more efficient way of doing things. So let's start. You're on IMDb's website like this, and we'll just find a movie. We're going to find this Hugh Jackman movie called Logan. Okay, and we're going to load it up on IMDb, and we'll also load it up on Metacritic. It's down here. Okay, so you can see here's the score on Metacritic. It got a 77 out of 100. And over across on Logan, sorry, on IMDb, it got 8.2 out of 10. So this is the data that we want to collect. And you can see at the moment we'd have to make 4,000 requests to put together our data set of 2,000 movies. But if we scroll a little bit further down, we can immediately see that IMDb actually lists Metascore on every single movie page. So by looking around, and in this case we didn't have to look around too hard, suddenly we've halved the number of requests that we need to make. And it's worth investing some more time at this point to see where you can minimize the requests. There's often different types of pages, search results pages, etc., on websites, and especially if you're just collecting some high-level data, that's really useful to minimize the number of requests. There's actually a page, which I will put in here, on IMDb, which shows movies 50 movies at a time. And included in that is, you can see both the IMDb score and the Metascore. So suddenly we're looking at going from 2,000 some requests to somewhere around 50 requests for the same amount of information. So it's really worth taking time to have a really clear idea at the start of the process of what data you want to collect, so that you can then explore around and work out what a more efficient way of fetching that data is.
Now, Josh, we're looking at it looks like a search that you built, a search query you built on their website to get the list that we're looking at right now. Is that accurate?
That is, yeah. So Alex, when he was putting together the blog post, explored around and found this page. And what particularly makes this page suitable for the technique that we're going to use today is that in the URL, there are a number of parameters. You can see it says release date equals 2017. And then further on, it says and page equals 1. And you can actually play with these numbers. If I change page equals 1 to page equals 2, and just take note here, we're looking at 1 to 50 down here. And I'll just press enter to load that page. And you can see now that it's now saying 51 to 100. So what that allows us to do is, just by changing some of the parameters in the URL, and the parameter is just a fancy name for the things that come after the question mark in the URL, we can easily make a few changes and fetch down a number of different pages. So let's start by writing some code. We're going to use a Python library called requests. It's a built-in, actually, maybe it isn't built into Python. I don't think it is.
Yeah, you have to pip install requests.
Yes, so you need to install this, but it's very easy to install with pip, and I'm almost certain that it would come in a standard conda installation. So we're going to import the get function from requests, and we're going to use that URL that I was just at, and to fetch the page, we're just going to say get and this URL string, and I'll assign it to a variable just to make it easy for us. Okay, and the requests library basically goes and fetches that file, and let's look at what it's come back with. It's come back with a 200, and a 200 is just a response code, which means which indicates that the request is successful, and we can use the text attribute, and it will actually fetch all of the HTML behind the scenes in this page, and you can see that there's quite a lot of it. Okay, so now we need to, now we've basically done this stage here from our initial diagram. We've got the website, we've found a web page, we've made a request, and we've brought down a local copy. Now what we need to do is extract from that web page the pieces of data that we're interested in. So let's work out what pieces of data particularly we want to fetch from the page. Let's go back here, and we'll look, sorry, to this page here, and I'll go back to here. So we've got this Logan film. Obviously, the name of the film is something that we would like to get. The year that it was released would be an interesting piece of information. Obviously, the IMDb score and the meta score, and the number of votes as well that it's gotten on IMDb is useful as well. So what we need to do is we need to work out what HTML in that page corresponds with all those different pieces of data. And what we can do is we can right click and click inspect. Now it's called a similar thing in most web browsers. I'm using Google Chrome, but most web browsers will have a similar function with an inspector. And this allows you to, you can see as I move my mouse over different parts of the code, it actually highlights parts for me, and it makes it really easy to find where the data is coming from in each page. If I collapse this here, you can see there's a bunch of these div, and it says div class lister item mode advanced. And as I go through each and scroll down the page, you can see each one of these represents a movie. And so what we're going to do is we're going to start by extracting these to make sure that we can easily find each movie from the web page that we've extracted. And what we're going to use to extract this data is a library called BeautifulSoup, and it's, I think, the best parser for parsing web pages, and actually things that aren't web pages as well, XML files and things like that in Python. So we're going to start by initiating a BeautifulSoup object. And we're going to put response.text in here, which is this variable from up here. And we're going to tell BeautifulSoup to use the HTML parser. And so we run that code, and we'll just have a look at what type file it returns, and you can see it returned this BeautifulSoup object. Okay, and then this BeautifulSoup object allows us to then drill into this file and look at different HTML elements and extract the data. So we saw on this page here that we had this lister item mode advanced, and that they were all these divs. So we're going to use a method of this object, which is called find all, which cryptically finds all of something. And we're going to find all of the divs. And we're also going to pass this class parameter, and this enables us to put this lister item mode advanced, and it allows us to return all the divs from this HTML file, which is now just a text variable in Python, and it's going to return an object. We'll call it movie containers, and then let's have a look at movie containers. We're going to print the type, and we'll also print the length of it. Oh. Okay. Okay. I just dropped the D when I pasted that in. Okay, so we can see that it's returned a result set, and we can see that there's 50 of them. And that gives us some confidence that this is what we actually wanted it to be, that there's 50 of them on the page, and that it's each one represents a movie. We can actually have a look at each individual one though, so let's do that. We're just going to use indexing, just like you would indexing a Python list, and look at the first movie. And here you see some more code, but if you look at this, it starts with 3 divs, the outer div, lister item mode advanced, lister top right, and ribbonize. And if we go back here and open this first one, you can see these lister mode advanced, top right, and ribbonize. And this shows us that this is what we've actually got, this this class list that represents one film. And now we can work on extracting all the data from it. So let's now look within this top div. Let's look and see if we can find the first piece of information that we want to extract, which is the name of the movie. Okay, so we see that there's, we can do this 2 ways. We can right click on the movie and go inspect, and that will actually open up exactly where we are. And you can see that there's 1 div, 2 div, 3 divs. And in fact, let me just bring in this. Makes it a little bit easier to see. Okay, so you can see there's the first container that we've got an open, and within that there's 1 div, there's the second div, there's the third div, there's an H3, and then our movie title is contained within this A for anchor tag. So let's try and just extract the first anchor tag and see if the data that we want is there. And what we do with this is we'll just type first movie dot A and see if we get our result. Okay, and it looks like unfortunately the first anchor tag is not our movie title, so we'll have to work a little bit harder from that than that. There's a little bit of hunting around that sometimes you need to do. Let's look at this H3 that we saw before, and let's change this first movie A to first movie H3. Okay, now we can see we're a lot closer. We have in here the movie title, and the movie title is within the anchor tag. So we can actually add this H3.A, and suddenly we've got just that single anchor tag that's got the movie's name in it. So you can see with BeautifulSoup, you can actually drill down through the different HTML tags, and you can see within that you can go to the first H3 of this container, and within that the first anchor tag, and we're very close to having the text that we want for our movie name. Now you can see there's the open tag and the close tag, and we just want what's within it. So BeautifulSoup has a text attribute. We can just do that, and it returns the text as a string. So this is actually, we've now established our our first thing of extracting the first name. We'll just assign it to a variable there so that we can use it later. Okay, so the next thing that we want to look at is we want to find the year of the release of the movie, which is from here. And you can see actually it's not far from where we are. You can see that there's this this span class straight underneath, which has the movie in it. And we can see that there's this lister item year text muted. And so again, like a lot of things with web scraping, there's some hunting around, but there's a good chance that this lister item year is unique to this particular thing. So let's go back to our code and we'll go to the first movie container again. And inside that H3, we'll say find span, and we'll use the class parameter again and see what comes up. And you can see we have gotten a unique match, and we've gotten this 2013 in the span. And just like we did before, we can just add text at the end, and suddenly you've got a string representing the year that the movie was released. Now you can see that it's not clean. There's some parentheses at the end. We're just going to leave this as it is for a while. We're going to sort of, in this particular instance, resist the temptation to clean it. One of the key reasons that we're resisting that temptation, if you scroll down through these movies, you'll see that some of them have an I in parentheses beforehand. There's one, this 13 Reasons Why movie has 2017 in a dash. So they're not all similar. So it's better for us to collect them all, and then we can worry about cleaning them into a neater format later. Okay, so again, let's assign this to a variable. We'll call it first year. Okay, so now we've got our first two pieces of information. The next we're looking for is the IMDb rating. Okay, so again, a handy way to jump directly to what you're doing is to just right-click and go expect. And you can see that the IMDb rating is in a strong tag. Now, if you remember the first thing we tried with the movie title, we just tried the anchor tag just to see if it might be the first one and see if we'll get lucky. We'll do that again with this. We'll just say .strong. So let's go first movie .strong. In this case, we have struck it lucky. So it's worth trying these, because if it is the only or the first instance where you have things inside a particular tag, you can make life easy for yourself. So we can access this by saying text. And because we know that this information is uniform, we can actually convert this to an integer and assign it to first IMDb. Oh, of course, not an integer, a float. Okay, and so now we have that data. Metascore, again, you will be noticing a similar pattern. Now the Metascore is in its own class. So you can immediately see with this, as you look at each one, there's sort of different techniques that you can use. And because you can see this Metascore favorable, that gives you an indication that you can use that find all class with the span to have a look. So let's try with that. We'll go back to Jupyter. And there's our number. We can go text to extract it. And then this one we can cast to an integer and not a float. Call it first N score. The last thing that we want to capture is our number of votes. Okay, so back to our inspector, and we have votes down here. And you can see this one, it's in a span tag. It doesn't actually have a class though. It has this name attribute. So we can't use find with class, but there is built into BeautifulSoup the ability to find these sort of custom named attributes. And what we do to find that is we do first movie, find, we're looking for a span, and then there's this ATTRS, atts, like a shortening of attribute, and we can actually pass that a dictionary. Name NV. And here we get the span that we were just looking at. Now, we could just use text to extract that number. It does have a comma in it, and we could easily clean that out later. But it's interesting to note that there's this data value here where this number is there, but it's cleaner. We can actually access that by using brackets and by going data value, and we extract that number straight out as a string. Okay, so we will assign this to first votes equals to integer. Okay, so we've just extracted for the first movie on that page the movie name, the year, its IMDb score, its Metacritic score, and the number of votes that it has. And what we can actually do is we can write a loop to loop over that one page that we've already scraped, and go through all 50 containers and extract that information out. Before we do, it's good to become familiar with the structure of the data. And if you're looking at this page and scrolling through, one thing you might notice is that while most of the movies have a Metascore, some of them don't. See this movie here, 13 Reasons Why. This doesn't have a Metascore. Presumably it's because that movie is listed on IMDb but not on Metascore. So what we need to do is we need to be aware of that, and we need to write a condition in our scraper so that it doesn't look for this Metascore number, because it's gonna throw an error in our loop if it does that. So what we can do is we can use the find all method that we looked at before. And when find all doesn't find anything, it returns none. Let me just show. We're going to look at the. I'm pretty sure this was the 11th movie on the page. Yeah, so we're going to look at the 12th item in moving containers, and we're going to say try and find this ratings Metascore, and oh, sorry, it's the 12th, but it needs to be. No, it's the 11th, but it needs to be 10 because there's 0 indexed. Sorry, I went the wrong way. I added 1 instead of. Okay, and nothing comes out, and we can actually use is none here to explicitly see that this is returning a none object. So we'll be able to use this as a conditional when we write our loop. Okay, so let's actually write the loop. Let's start by creating some lists to store our data in. We're going to create 5 lists here: names, years, IMDb rating, Metascores, and votes. And we're going to start by for container in movie containers, we're going to iterate over that BeautifulSoup object, remembering that movie containers is this result set of 50 items that we created earlier. And for each item, the first thing we're going to do is we're going to look to make sure there's a Metascore. Because the whole purpose of what we're doing right now is to compare Metascores with IMDb ratings, we're actually going to not even record any movies that don't have both scores. So if this search for the rating metascore is not none, we want to do, we want to pull down the data. And I'm literally going to, I'm going to copy paste this in, but it's exactly the code that we had above when we found these one by one. So you can see for the name, it was in .h3.a. For the year, it was .h3, and we used find to find the lister item year. The IMDb rating, remember, was found directly in that strong tag. And for Metascore, oh goodness, I've got an incomplete paste. For Metascore, we use that find span again. And for the number of votes, we use this, this attribute parameter with the custom dictionary and pulled out that data value. Okay, so when we run this, it will pretty quickly loop over that file over those 50 containers in the results set. And let's look at what we got and make sure that it looks good. So we can use Pandas. I like using Pandas just because they display data frames so well inside Jupyter. We're going to create a test data frame. And I'm going to say test data frame.info to start collected. Okay, and we can see that of those 50 results, we see that there's 35 rows here, which means that 35 of the 50 had both a Metacritic score and an IMDb score. And then we can actually look at the data here. And you can see that everything looks like it worked pretty well. You can see a case of this year where it's got the extra information. But we've collected 50 movies worth pretty quickly. Okay, so this is actually, most of the hard work is now done. All we now need to do is to automate doing this for multiple pages to collect our data. Okay, so if we remember back to, oh, I accidentally closed that page, let me reopen it. Back to this page, we were looking at changing the release date in the URL and the page number in the URL to collect a number of different movies. Okay, so let's create some lists that will help us in Python to do that. We'll just use list comprehension. If you haven't seen it before, it's just a concise way of creating a list using the same sort of syntax that you would in a loop. So this one here just creates a list that contains the numbers 1 through 5 converted to strings. And this one, the numbers 2000 through 2000 and, sorry, 1 through 4, because the last number is not included. And the second one, 2000 through 2017. You can see we assign these to pages and years URL, and this will just allow us when we write our loop to loop over and collect all the pages. The next thing that we need to be aware of is that we can't just say I've got these what is this, 17 times 4, 70 something requests. I can't just make those all in a row, or I can, but I might not be successful. We want to actually put some pausing between making those requests so that we are both taking it easy on the web server that we're trying to do, and we're also lessening our risk of, you know, triggering any protection that they have built in that might lock us out from being able to scrape. So we're going to use some Python modules. We're going to use the time, and we're going to import the sleep function, and we're going to use the random integer function. We're going to do this in a pretty crude way, but it actually works quite effectively. We can, in fact, let me just import the whole time module. we can say loop 5 times, and we can say here's where I make my request, and then we'll ask the program to sleep for somewhere between 1 and 3 seconds. And we'll just look at, oh, sorry. You'll see here, oh, random was pretty unrandom with those last three, with those last 3 iterations, or maybe it was very random. You can see that at this small scale, there's a pause and then it prints, or sorry, it prints and then it pauses and it repeats that. And we're actually going to use that. We're going to use that to put some spacing in. The other thing that I like to do is we could print some output for like every single line, but this script's going to create about 70 requests, and that can get messy, and certainly when we're looking at it here. So I sometimes use this this IPython core display. It's from the IPython kernel. It just allows us to clear the output as we write it, and I'm going to just paste in this code. And you can look at this in the blog post. I'm not going to go into too much detail. But what this basically is going to do is it's going to do a similar loop to what we did before, but each time it's actually going to print us a little message and tell us how our loop's going. Oh, sorry, I apologize. That should be good now. Okay, and you can see as the loop goes over, each time it updates this request number and this frequency of requests. And this is nice. It means you can keep an eye on it without necessarily having to pour over 70 lines of output. The last thing we're going to do is we're going to, because this is going to take some time, we're going to pause between 8 and 15 seconds between each request. We don't necessarily want to throw an error if there's a problem. It might be nice to know that there was something that went wrong that we can look at later, but not actually halt the whole thing. So we're actually going to use, Python has warnings, which are really useful for this. So we're going to import warnings, import warn, and just to show you what that looks like. And it's beautiful pink thing, and you can customize this with information. So we're actually going to use this to feed some output in case something goes wrong. Maybe the internet connection goes down while we're scraping. And often, if you've got a large job, you might want to schedule this and hit go and go to bed. It's nice to have some data about what happened if it failed in the morning or if part of it failed that you can do. So let's create our loop. We'll start by reinitializing these lists. We will initialize these sort of status monitoring. This is literally what we did in the cell above us. And the only thing that we're going to do different, or one of the only things that we're going to do different from our last loop, is we're going to iterate over that year's URL that had the numbers from 2000 to 2017, and we're going to iterate over this pages as well. And for each iteration, we're basically going to take the URL we had last time, and under release date, we'll put in the year URL, and under page, we'll put in the page URL. And I will remove that because we don't need to worry about that parameter. Okay, and after that, we're going to pause for between 8 and 15 seconds. We'll then add some information to throw a warning. So if you remember right at the beginning, in fact, I'll go up. We looked at, just put it in here. we saw that you got response 200, and we talked about how 200 meant that we'd successfully crawled the page. What we're going to put down here is we're going to say if the response code is not 200, so if response status code is not 200, let's issue a warning, and we'll say what the request was, which number it was, and what our status code is, and that'll give us some indication that something went wrong, and then we might want to look at how successful. Sometimes we might still be happy with the information that we pulled down. The other thing we're going to do is maybe being overcautious, but it's always nice to be overcautious. We can multiply out these 17 times 4. We actually get 72. We're actually going to, because we're setting this up as if we were going to leave this to run overnight, we're basically saying if the number of requests go over 72, if somehow we had badly constructed our loop to run infinitely, we're actually going to break out of the loop so that it doesn't keep going forever if we're planning not to watch it very closely. Okay, and then all we do is insert all our BeautifulSoup passing code from before. So we pass the page, we then iterate over the containers like we did before. We check if this particular movie has both types of ratings, and presuming that it does, we scrape the name, the year, the IMDb rating, and the number of words. Okay, now this is going to take about 16 minutes to run, and I'm not going to make you sit through 16 minutes of boring output. So before we started, I put one in the oven, and you can see here the output of our code. The 70-second request came in. The frequency was at 0.07, which is about the average of this between 8 and 15 seconds. And we have some data, or we think we have some data. Let's have a look. So again, we'll use Pandas to create a data frame. And this is, I didn't really go into detail before, but this is quite a handy way. I construct data frames like this all the time. You just feed a dictionary to the data frame function, where the keys of the dictionary is the column names, and you can, any sort of iterable type object like a Python list is the values. So let's do this, and again we'll start by looking at info and see how much data we got. So we got 2,887 rows. You can see none of them have null values. So we've got well above our what we set out to do of 2,000 movies. And let's have a look to at the data. Okay, so obviously we're starting from the year 2000, and you can see all this data looks good. And you can also see here in the info, you can see that our types are looking good. If for some reason there was some bad data in here, that there was some invalid characters, Pandas wouldn't make these floats or ints. They would all be objects, and we would know that there was some extra cleaning required. So speaking of cleaning, let's tidy up this data and do a little bit of sort of quick analysis on it. So we'll start by making the columns a little bit more sensible order-wise. So we'll start with the movie and then the year, and then the two sets of scores and then the votes. Oops. Okay. Now let's look at this year column that we talked about, that we were going to defer cleaning this up. So one way when you're dead cleaning, I guess one of the most important things I think when you're dead cleaning is to get a quick view of the range of values. So we can go movie ratings. I can spell ratings. And I'm going to use the dot accessor because it's a bit lazier. And we will say unique. And this is all the unique values we have here. Now, it's a little bit messy because of how it prints out. But if you examine these for a little while, there's a number of different ways you can extract these numbers out. You could use a regular expression, but one way without diving into the complexity of regular expressions is that all of these values, they actually end with the year number and then a closed parenthesis. So we can actually use their position in the string to extract them. And it's a nice, neat way to extract them without having to worry about constructing a regular expression, which I know, as much as I love regular expressions, that a lot of people, when they're starting off, it's something that they'll sort of actively try and avoid. So let's go with the regex avoidance. And we'll access this year, and then we go .str, and that accesses the these are the pandas string operations, and most of them are literally almost like a wraparound of all the Python string methods. We can actually just use slicing on the string, just in the same way with let me just show this because it might be something that not everyone's aware of. If I have a string like hello, I can actually access the first character of the string and access the H, and I can use list slicing access specific characters. So in Python, a string is just like a list of characters. So once I've used this string assessor in Pandas, I'm going to go from the fifth last character through to the last character. And let's just quickly take a peek at what's happening here. And it looks like that's worked pretty successfully, at least on the first 4 items. And then we can just use as type str to make this a string. And let's assign this to movie ratings. What have I done wrong here? Just bear with me a moment. Oh, type int, not as type string. Okay, there we go. I actually missed the lock statement when I was assigning it. Okay, that's better. And we'll take a quick look at that data again. Now you can see that it's 2000. You can see that the type of the column is an integer. Okay, and now we're free to explore the data. So we can use some pandas. Movie ratings, describe. You can see here the IMDb scores range from 1.4 to 9, and the meta scores range from 7 to 100. Let's actually move those to the same scale. So let's add a column, multiply the IMDb ratings by 10, and that's going to allow us to just quickly create some plots where they're on the same scale. And again, for time, because I'd like to leave us some time for some questions, I'm just going to paste in this plot. But basically, we're going to create a histogram of each distribution, and then one where the 2 distributions are plotted over the top. And you can see the IMDb rating and the Metascore. And you can here see that the IMDb ratings are definitely skewed a lot higher than the Metascore ratings. And obviously, you know, if this was a proper project and not a web scraping tutorial, we'd sort of dive in and do some further analysis. And hopefully that's been helpful and shown you a lot about web scraping. One of the things that when I'm talking to people who are doing web scraping, one of the things that I've noticed as I've learnt web scraping is that each the techniques that you use are quite simple. Accessing accessing the values through BeautifulSoup uses a very similar syntax, and obviously creating the request is quite simple as well. A lot of the work in web scraping is actually spent in the web browser expector, trying to find all the bits of data, and there's no. It's actually very similar to working with APIs. Someone said, someone said to me the other day, "Oh, I did this API tutorial, and it seemed like it was very specific to one API." And the unfortunate thing is, when you're collecting data through APIs and web scraping, each one is unique, and you need to almost have a fresh approach. And there's a lot of trial and error with each new API, with each new web scraping project. So a lot of the things that we move through a little bit quickly at the start in the variable inspector, where the sort of answers were magically in front of us. Know that when you're doing that, that is going to take some time. That is going to be a little bit frustrating for you, unless you're someone like me who's a little bit perverse and likes a challenge. That is going to take you. That is going to take some time. There's going to be some trial and error there, but hopefully that's part of the fun.
Well, also with D4D, we have a strong community of people that are very well versed in web scraping. So there's more than one way to solve a problem. And if you get stuck, feel free to tap the community and ask questions. Something else that, to your comment about, right now, yes, this tutorial is for IMDb. Right now, a friend of mine and I are trying to scrape old Greek text, and the site, there's so many edge cases that when you're like, okay, we think we're good, click play or click run, and you're like, all right, it's going. Okay, we got another edge case. So like, don't give up. It's that perseverance that'll eventually get you the data that you need.
Yeah, absolutely. And it's I think it's quite a lot of fun, actually. Like, it's a little bit of a game of like how many edge cases are there? Like, can I cater for them all? I know that as I was saying, one of my first projects for mine, just to sort of learn web scraping, was presidential election results. I'm quite interested in politics. I'm, as my accent might indicate, even though I'm based in the US, I'm not from the US. And it was frustrating news to me to find out that a week after the presidential election, the results are not complete. And that I was finding that while the result of the election is obviously complete, county reporting is not at 100% for sometimes weeks and months afterwards. And it's not actually until, now don't quote me on this, but somewhere in the new year, I think, close to inauguration, that the full complete results are not sort of given to be, this is the official results, all counties are reporting at 100%. So you'll find quirks like that. I was like, cool, election's been over for a week, I'll grab down all the county data and then I can start doing some analysis. But you'll find that sometimes that's not the case. That those warning things that we used, I created those for myself in that original project to throw a warning whenever there was a county that didn't have 100% data, so that I could sort of track those over time. Wow.
Well, thank you again so much for taking the time to walk us through BeautifulSoup. It was very enlightening, very soupy. So thanks again. And until next time, community, have a great day.
Bye.